Alina sails her boat from Port P on a bearing of 70 degrees. With bearings, we always start from the word from. As it's accurately drawn, we now get our protractor. We put the centre of our protractor where we're starting from, in this case from Port P, and we always assign 0 with 0. We always measure clockwise on the outside. In this case, we want to reach a bearing of 70 degrees. So here's our 70 degrees, put a little marker. I now get my ruler, joining it up to Port P. Everywhere on this line here, that's a bearing of 70 degrees from Port P. As we're told, she sails for 1.5 hours. That's her time. An average speed of 12 kilometers an hour. That's her speed. Therefore, I need to work out her distance. So drawing my formula triangle, I know Dad's C triangle, distance, speed, time. You always cover up the one you want. As I want distance, I put my finger over D and whatever left of my formula. So therefore, distance equals S, which is my speed. You should know that a vertical line in a formula triangle means to multiply. So it's the speed multiplied by T, where T is their time. Substituting in our values, I know her speed is 12 kilometers an hour, and it's multiplied by her time. Her time is 1.5 hours, which as a decimal is 1.5. And 12 times 1.5 will give us 18 kilometers. Another way to get 18, as she's travelling at 12 kilometers an hour, and she's travelling for 1.5 hours, well, I know 1 hour, therefore will be 12. And half an hour will be half of 12. Half of 12 is 6. And 12 add 6 will give us 18. Looking at our scale, we know 1 centimetre represents 4 kilometres. So if we're going from centimetres into kilometres, we would multiply by 4. And if we're going from kilometres into centimetres, we'll do the opposite, which is divide by 4. Therefore, as we're going kilometres into centimetres, I'm going to divide by 4. So I'm going to have 18 kilometres on the top. I'm going to divide by, in this case, 4. And 18 divided by 4, when dividing by 4 on a non-calculator paper, you could keep halving it. So half of 18 is 9. And half of 4 is 2. And 9 divided by 2 gives us 4.5. Therefore, to locate Port Q, we're going to go 4.5 centimetres on our bearing of 70 degrees. So getting our ruler from P, I'm going to measure 4.5 and put a little dot. I'm now going to label that Port Q. We're asked to find the distance in kilometres of Port Q from the lighthouse L. If we're finding a distance, my first step is just to draw a line connecting my Port Q to the lighthouse L, and to measure the line as it's drawn accurately. So drawing the line, look at my ruler, I can see that comes out to be 5.5 centimetres. As the distance is 5.5 centimetres, and I want my answer in kilometres. Reading my key, I know 1 centimetre represents 4 kilometres. So when going from centimetres into kilometres, I'm going to then multiply by 4. So here, 5.5 multiply by 4. When times it by 4, you can just double it and double it again. Well, double 5.5 gives 11, and double 11 gives us 22. So therefore, 5.5 times 4 is 22, and that's in kilometres. I now want to find the bearing of Port Q from lighthouse L. Again, with bearings, we always start from the word from. Therefore, starting from L, we always go north. We always measure clockwise until we reach the bearing of the line, in this case, our line of Q. Again, as it's accurately drawn, we can use our protractor. As most of us have only a half protractor, in this case, it's much easier to measure the small angle. So placing the centre of our protractor on L, our lighthouse, and lining up on 0. The angle is 10, 20, 30, 40 degrees. And as we want the angle in green, we know angles around a point always add up to 360 degrees. So hence I'm going to do 360, subtract 40, which gives us 320. So the bearing of Port Q from lighthouse L, this bearing here, is 320 degrees. A reminder, bearings is always given us 3 figures.